In NX14, we introduced an amazing feature that allows you to leverage Module Federation to speed up the local serve time of your application, as well as the build time, obviously, locally as well as in CI. Now let's have a look how you can do that with NX on the example of an Angular application. So I prepared already an NX workspace, which has here an Angular application and a bunch of libraries. Let's have a look at the project graph to understand how our workspace looks like. And so we have the shop application and we have a checkout, orders, and product catalog library. And this is a common architecture setup if you develop Angular applications within an NX workspace. Now, technically, this could already be considered a monorepo because we have one application and a couple of libraries. But if you look at the structure, all those libraries are really dependent on just the shop application. So they are not there to basically be shareable across multiple applications, although it would be pretty easy to add another app in here. This is a common pattern when you set up Angular applications within an NX workspace. And it is simply because this library structure gives a lot of benefits, starting from team allocation, because every team that is specifically in charge of a given domain can focus on a subfolder in that libs folder or a given library. And there's not a whole lot going on at the top level, at the application level. And as you can imagine, it also helps with merge conflicts. But let's focus more at the build and test time optimizations that such a structure gives us. First of all, we can now run tests, lints, and whatnot on the individual libraries rather than always having to run it on the entire application. So we can do something like NX test checkout, and that would just run the test for the checkout library. But more importantly, NX also comes with the NX affected commands. And so we can do something like NX test, affected test, and that would only execute tests that got affected by a given PR. And NX does that by looking at the actual Git commits that happened compared to like a reference branch, which is usually the main branch, like main or master. So as you can imagine, this can already help speed up CI runtimes a lot. However, there's still one problem. Let's have a look how these libraries are being linked to the application. So right now the setup is very lightweight. So at the level here of the app module, I basically have a router definition where I pull in lazily all these libraries. And I can do that by directly referencing it in an npm scope-like fashion, where this is the actual name of my workspace, of my NX workspace here, and this is the name of my library. And so this works because at the root level of our workspace, we have a tsconfig.base.json, where we have various path mappings that point to the actual entry point TS file of the various libraries. So that means that at the build level, whenever we build the shop application, all the sources get pulled into one single build, which is done by Webpack in this case, when we use an Angular application. So you might experience actually very slow build times at some point as your application grows, simply because you're doing a one monolithic application build. There are different ways how we could actually mitigate that or help with that. One way is to actually create buildable libraries, and you can check our NX docs on how to set those up. There's actually a generator that helps you create those. But what happens there within a buildable library is simply that it gets an ng packager set up for Angular-based libraries, meaning that the library, whenever it is being used, it gets first built. It creates like JS artifacts, similar to what the Angular CLI produces when you use ng packager, and that artifact gets then consumed by the Angular application. Now in NX, we have wired it up very nicely in a sense that you don't even see that. It happens behind the scenes. You still think you're consuming from the sources, and therefore debugging and like following the actual source files works just as expected. However, when NX builds the application, it recognizes there's a buildable library and behind the scenes builds it and then references that build artifact rather than the TypeScript source. So this works nicely. However, it comes with some downsides as well. ng packager is actually quite heavy. So it can be quite slow when you build, and even though you get the benefit then of caching, of course, if you start with a cold cache, meaning you don't have any cache hits, you might actually experience slower runtimes whenever you serve your application locally or build it on CI than if you would consume it just directly by using the normal TypeScript path mappings as we do in the NX workspace. Furthermore, there's another thing. Even if we would have all incrementally buildable libraries, you would still have the linking time at the application level. So whenever Webpack then links the libraries together, it might still take quite some time depending on how large your application is. So the only way is really to slice your application to multiple pieces. And in NX 14, we did that by leveraging module federation, but with the particular goal of not having a worse developer experience than if it would be a single application. So let's have a look how we can actually change the structure to leverage the new module federation setup. So the first thing, what we can do is we can add some module federation support to this shop application. And we can use an NX generator for that. So I just run NX generate and I write setup module federation. And so the app name that we're using here or want to change is the shop application. And we can leave most of the things in here. We want to have static linking, meaning we just want to have the same experience that we usually have by building a single application. We can set here the module federation type as host, because this will be our host application in the end, where we consume the various remote applications. And that's basically it. So let me just run this, and then we can observe what got changed by NX when it ran this generator. So we can see here we got a module federation config setup that basically defines this one, this shop, and it doesn't have any remotes right now. It comes also with a Webpack config, which imports here from the now module federation setup. It wraps it basically with this with module federation, which internally leverages a couple of optimizations that NX can do for you by using the project graph and therefore understanding how the project relates to the various remotes that we're going to create. Finally, there's also a production file for that config, so we can fine-tune that whenever we deploy this into production. We will have a look at that in a minute. And NX also changed in the project files which execute its uses. So rather than using the Angular devkit build Angular, it now uses the Naval Angular Webpack browser, simply because this allows it to provide some custom Webpack configs behind the scenes. And let's surf our application to see whether it still works as it did before. Let's go to localhost 4200, and we see our application still works. It still pulls in the various libraries lazily that we had before, because we didn't really change anything on the setup itself. The next step is to actually go and transform all our current lazy imported libraries and now import them via dedicated module federation remote applications. And that's how we actually slice our application, because in the end, what we want to do is we don't want to have here one single application build that imports these modules here just lazily via local chunks. But what we want is to reference the actual module federation setup that we are going to generate. So the first step we can do is let's create a module federation remote application for this checkout domain. So again, what I'm going to do is I can run a generator, and I call this remote, and we choose the Angular remote. The name would be checkout remote. And we can leave the ports as is. We want to give it the host, which would be our shop application. So this will already tell NX which application is the host and therefore do some optimizations for us. And we can leave all the remaining settings as is. So let's run this. And so what we should get here is a new application up here, which is called checkout remote. You can see it also has a module federation setup. This now is a remote entry point, so it already also exposes an entry point module, which it contains in here, and a couple of other Webpack Module Federation setup related things, as we have already seen before. Now, since we also gave it shop as the reference host, we can go in here and we can see that it did a bunch of optimizations for us already. So in the remotes array of our host application here, of our Module Federation host application, we see it already inserted the new checkout remote that we just generated. And furthermore, it also added a lazy route here that now loads our remote entry point that gets compiled via Module Federation. And so we can actually leave this and refactor our application by taking our original checkout route, remove that one, and we want to basically change this one to just the checkout route. So in this case, it behaves the same as it did before, but now it doesn't load the local library lazily, but it rather references this remote application, which should be built by a Module Federation. Next, let's go to our new module federated remote setup here. Let's go into the routing. And so here it loads our entry module, which we want to still keep as is, because this entry here serves as our entry point basically when it gets compiled via Module Federation setup. So I'm going here in this entry module page here, and I adjust the routing configuration to use our checkout routing. I'm going to use here an empty path just as here, so we can remove this one and also clean up the remote entry component because we don't really need it. This is just a shell for us to now load the lazy library, which lives down here in that libs folder, just as it did before. So rather than importing that checkout now in the shop application, we reference it directly from the checkout remote application. Let's now see whether this still works. Let's go ahead and again serve our shop application. You can now already see it already builds the checkout remote because it saw that dependency during the build. You see there's another server being spin up, which is on 4201, and then there's our 4200 port, which is our application. So let's refresh here. So we see the product still works because we didn't really touch it. The checkout now also works, but this now points to the actual remote application, and the orders page, which we also didn't touch, still obviously works as well. The interesting part is that this checkout application is now being served independently via that remote, which lives on 4201. So NX did spin up a server on that port directly. And if we open that, we can see that here our checkout page runs, which is an independent application if you want. It just happens that it gets pulled in here via the Module Federation setup. So let's go ahead now and refactor our product and orders modules as well and create according remotes for those two. So again, I go to the generate page here. I choose the remote generator. This would be the product catalog remote, and the host would be our shop application. And we can actually go and copy this so we can reuse it for our orders page as well. So now we see we generated a new product catalog remote, which corresponds to this one. Now as needed, we also need it for the orders page. So let's reuse this copied command here, and let's call it here orders remote. The host still remains the same. Let's generate this as well. Let's use CSS for it. And now we should also have the orders remote. Now again, we do the same trick. So let me close a couple of windows here first. But I'm going here to my shop application, which should now have already imports for orders remote and the product catalog. So let's start with the product catalog. And so that route initially was the one up here. So let me remove this route. Let's change this one here to be the same as it was before, but now it actually pulls in the remote as we mentioned. And so let's go to the product catalog remote. Let's go here in the entry module and let's replace here this one by using now the actual product catalog endpoint. And again, I'm using the default path. So whenever this module gets loaded up, it should directly pull in the product catalog library and load that up. Same thing for the orders remote. Let's again go to the shop application. And here we want to change this to be just orders. And we want to find the orders mapping here in our router and adjust that in the orders remote. So let me go to the entry module and actually replace this one with a new orders route. Now again, let's serve our application. You can now see it also loads the product catalog remote first and builds that one, the orders remote. And then finally we can go to 4200 and reload our application. And you can see it still works just as expected. So this setup has a couple of really cool benefits. If we go back to our code structure and have a look at one of these remotes, these are really just normal Angular applications. So we can see there's still a bootstrap file, there is an app module. And so all we can do is really just serve them as we normally would. So we could say nx serve checkout remote. And so this is being served at localhost 4201. And if we load this up, we see our checkout application being served as an Angular app independently. And so this is really cool because now if you're part of the domain team that covers the checkout area, you can serve your own application without having to serve the entire application, so the full-blown app, and obviously benefit from the speed improvement because you're just serving a small slice now of the entire application. And obviously apart from that setup, there's still the remote entry point, which you have seen before, which gets activated whenever this application gets served as part of the module federated setup, which, as we have seen before in this case, would then look like this. With the next, however, we wanted to go a step further. We didn't want to change the developer experience just because you happen to use module federation in this case to vertically slice your application and get a better serve time locally. Rather, we wanted to keep the same experience such that you can just serve the shop application and it would handle implicitly the loading of the single remotes, the embedding of the remotes, and you should, however, still get the same benefits in terms of speed as if you would just serve a single application. So let's see how. So now I serve just the entire app again as we did before, and it still works. We can see all the pages still load as we expect. Now look what happens if I run this a second time. It is basically immediate. The only build you're really seeing is of the shop host application itself, because that needs to be built and served. And again, we see our application load up. Now, what happens, however, if I just want to work on that remote app here? So I go here and follow the path of what I have loaded here, which is the case, in this case, the module federation demo checkout page. So let me actually go down in this library in the checkout page. And let's say we change here couple of exclamation marks. It would rebuild. If I go here and go to the checkout, I, however, only see one exclamation mark. And the reason here is because by default, NX serves all the applications just from the cache with a static local HTTP server. So that's the actual benefit. So once you have served the application or you maybe have built it on CI, you get the cache and therefore this whole speed improvement. Now, if you decide to work on a checkout domain, what you can do is you can use the serve command with a special flag. You can use NX serve shop dev remotes and you give it checkout remote because that's the application you work on. You could even give it multiple if you work on multiple domains. And what happens now is that NX will not use the static server and serve checkout remote from cache, but for that single slice of that remote for the checkout, it would just use the Webpack dev server as normally. So if we go here to the checkout page now, we see the exclamation marks. And again, obviously, if we go here and let's say fix this again, remove the exclamation marks and save, we see it already refreshed behind the scenes and gave us that speed improvement. But still, the products page as well as the orders page, those two remotes are just served from the cache and are therefore super lightning fast. So you still get the benefit of serving the entire application and seeing the whole context. However, you get also the benefit of the speed because you really just serve your own checkout domain page from the local source code with Webpack Dev Server. So let's have a look what the deployment looks like. Usually what you do when you deploy the application, you just run the build command. In this case, it would be on our shop application to create a production bundle. So let's run NX shop build production and then go to the dist folder. And what we get is our shop app. However, we don't get really the build artifact from the checkout remote and orders remote and product catalog remote, which you would expect. And the reason is these are not yet connected for NX. So if you look at the graph here, the NX graph, and we load that up in our browser here, you can see how these are basically disconnected pieces that only development are getting loaded properly, but there's the missing connection between the two. And so we can fix this by using implicit dependencies. So for the shop application, we can go into the project JSON, and then we can go to the very end here and add the property that is called implicit dependencies. And we add the various remotes that we have. So we have the checkout remote, and so now if we serve the graph again and refresh here, you can now see that these are connected. So shop properly recognized the checkout remote, the orders remote, and the product catalog remote. As a result, if we build our shop application again now, you can see that NX is basically building 3 dependent projects, which are our remotes, and then it runs the production build of our shop application. And so in the end, in our dist folder, we get all the 3 apps in terms of separate builds, as well as our shop application. So in a real-world deployment scenario, we need to somehow tell Webpack where those other bundles are, because locally in development mode, the Webpack dev server handled this for us. But when we deploy it, we need to configure this separately. And so to simulate this locally, I'm going to use a static server and just serve whatever comes out of our production build. And so we can configure those locations where those bundles live in production or in our simulated environment in that Webpack prod config that we have seen earlier. And this has a remote entry point. So let me configure one for the various remotes that we have. So we have here an entry for every remote. And so we have the checkout remote. And I'm going to serve that static server on localhost 8000 or 8080. And so we have here the checkout remote, which will be the folder name for where we deploy our remote. And this is based on the application by default, but obviously you can custom that and change that. And we need one for each of our entries here. So we have the product catalog. So let me change that here as well. And then we have the orders remote. And let me change this here as well. And so with that, we should actually be set up. Now let's remove the dist folder just to be sure. And then let's run the build for shop again. You can see most of it should be cached because we really just changed that Webpack prod config. And so if you go in here, we see our shop application and the various other applications. Now what we would want to have probably is an actual folder, let's call it production, which hosts all the files that we need to deploy in a nice and convenient way. So let me just move over directly all the files of our shop application, which will be the main host, and then all the folders of our remotes. So the final deployment bundle or package should look something like this. And now we should actually be able to go to this production and use an HTTP server to just serve this local folder. And so now if I go to localhost 8080, we see our application serve up. Our remotes seem to work properly. So this is nice because this is what we expected. Now, obviously for preparing our production bundle, we probably wouldn't want to copy and paste this manually every time. And so what we can do in NX is we can create a so-called run command to nicely bundle that script. And so let me create here a run commands. And we call it deploy, or we could also call it production build or something like that. Now the command, let me paste that in, will be exactly what we did right now, which would be to, first of all, remove the production folder, recreate it. Then we copy all from the apps shop, which is our host application, into that production folder. And then we copy all the folders that live in that dist output as well into the production folder. Now, the current working directory is important to be on dist. And this is because all the paths and commands here are relative to that dist folder. I could also prefix this here with dist/production, but it's more convenient to have it this way. And the project where I want to have this run command is my shop project. So if I run this, we should now get a project JSON updated in our shop application. So let me go there to that project JSON. And we should have here a new target that is called deploy. So basically what we should be able to do now is we should be able to just run the nx build shop command, which creates now all of the output in the dist folder as we want to have it. So with that apps shop and everything, let's remove here the production folder for now. And now let's run our nx run shop deploy command. And this would now run the deploy command that we created and produce our production output that we would want to have with the exact folder structure. Now you have seen that I first ran the build before running the actual deploy command. And the reason is if I remove the production folder or the entire dist folder basically, and then run npx nx run shop deploy, so the deploy target on shop, it would fail because it expects here an app folder in dist that it doesn't have. And so we want to have a relationship here between the deploy command such that it understands it first needs to run the build command. And we can actually go and quickly do that in our nx.json here by defining a target default. You can already see there is already one defined for the builds, which is the most common one, but we could just add here another one. It's called deploy. And it depends on the build command, not of its children, but just of the project itself. And so with that, we should be able to now run the deploy command again. So now you can see it first runs the build, it creates the dist folder structure such that we want to have it, and then it runs the production build or deploy script that we have. And so finally we get a nice folder with all the resources and output bundles that we need to have to deploy successfully in production. So that's it. I hope you really enjoyed this deep dive of how we can use NX to generate a module federation setup for an Angular application. And as we mentioned initially, the main goal here is if you have a large application and you want to improve the local serve time, module federation can be quite a nice technology. The main thing that we did is to slice our app into smaller pieces such that all of those pieces can be built individually, and therefore we can then leverage the caching from NX and NX Cloud to speed up the serve time, and also obviously the whole build time on CI. And so what we did is, first of all, we ran a generator to augment our current Angular application to be able to run in a module federation context, and specifically to serve as a host. Then we ran a generator to generate new so-called module federation remotes. And these are dedicated separate applications with already an entry point made at disposal, such that that application can, first of all, be served individually, but it can also then run within the context of a module federation setup with Webpack. Finally, we then stitched everything together. So we refactored our routing structure from the lazy loaded routes in the main shop application to move them out to the individual remotes. So each of those remotes that represents a domain in our larger application context loads in what belongs to its own domain. And then we again linked everything together. So our shop application loads in the remotes independently. And what we also have seen there is how you can serve the application just with a single remote in development mode, or you can just everything serve from a static cache locally. Finally, we have set up some small production and simulated how a production deployment could be by using a run command and creating a small script that really just moves around the files that got produced as an output. So if you enjoyed this, definitely make sure to subscribe to our YouTube channel. We have much more content like this that is coming up in the coming weeks and months. Also make sure to subscribe and register or follow us on Twitter, and see you next time.